Here we are at Algebra 1, Chapter 5, Section 1, Rate of Change and Slope. We need to do a quick review of ratio and rate. A ratio is a comparison of two numbers or measurements. So a ratio is a comparison. The numbers or measurements being compared are called the terms of the ratio. In comparison, a rate is a special ratio, so it's a type of ratio in which the two terms are different units. So here in example 1, we have Ron reads 5 books every 2 weeks. We're comparing 5 books to 2 weeks. That's our comparison. That's a relationship. So this is the only choice that compares the 5 books to 2 weeks. As you saw in our definition, a rate is always a ratio. It's a special type of ratio, so it's always a ratio. But a ratio is only sometimes a rate. Because a ratio is a comparison, and a rate is a comparison where they're different units. So a rate compares the two quantities by division. And again, a rate compares quantities in different units. The rate of change shows the relationship between two changing quantities, usually when one quantity depends on the other. The slope of a line is its rate of change. It describes the line's steepness. The definition of a slope is the ratio of the vertical change, called the rise, to the horizontal change, called the run. The slope is also called the rate of change. To use this vocabulary, you have two questions. How does the slope of a road affect a person's driving? You could compare and contrast what a flat surface someone's driving compared to a very, very steep surface. And then the second one, what kind of ski slope would a beginner skier use? Would they go down Mount Rushmore or would they go down a bunny hill? And again, you can tell me which one and why. The slope is often referred to by the letter M. M stands for the slope. And once again, the slope is the vertical change or the rise over the horizontal change, which is called the run. This slope is going to the right, and as it goes to the right, it's increasing. It's increasing, so that is a positive slope. This slope, as it moves from left to right, is decreasing, so it's a negative slope. This slope is staying constant. It's not changing. There's no rise, so it's zero rise over whatever the run is. So that's a slope of 0. This slope is a vertical line. It's an undefined slope because you have a rise, but your run is 0. There are two ways to find the slope. If you're given a graph, you can count the rise and the run. Well, actually count the lines, not the spaces. And if you're given points, we have a formula you can use. Let's go through each of these methods. On this page, we're going to find the slope using this graph. We will start by labeling each point on the graph with its coordinates. As you can see, this is point -3, +1. And moving to the right here, we have point 2. We go up 3. If you have questions with that, make sure you ask me in class tomorrow. Now we're going to talk about a vertical arrow to represent the rise. Notice I'm counting lines. I have 1 line, 2 lines. So my rise is 2. My run is a horizontal. I have 1, first line, second line, third line, fourth line, fifth line. So my horizontal hops are through 5 lines. Because the points are on the same line, the rate of change from point to point is constant. It's constant. That's what slope is. It's a constant rate of change. A slope is a rate of change, where the vertical change in this particular case is 2, and the horizontal change is 5. So this slope, this M, is 2/5. As I previously said, there were two ways to find the slope. We just counted the rise and the run. Now let's look through a way of using points and a formula to find the slope. In this example, we have a table. The table is talking about band marching over time. So remember, slope is a rate of change. Change in the different distance over the change in the time. So we're going to look at two of these. We can kind of pick whatever two we want. We're going to pick 2 minutes for 520, and then we're going to also pick 4 minutes at 1,040 feet. So my change in my distance started out at 1,040 feet and went to 520. Well, that's a change of 520. My time went from 4 to 2. That's a change of 2. Of course, as good mathematicians do, we reduce. So 520 divided by 2 is 260. So this rate of change is 260 feet per minute. Now that's per 1 minute, which is another reason we had to reduce it to get down to 1 minute. Is the rate of change we found the same as if we had used 2 consecutive rows? Well, look at the change. Look at the change from here to here. That's 260. Look at it from 520 to 780. Again, 260. And again. So yes, and then you can write out how you came to that conclusion. There's a formula for finding the slope. Your slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which, as you realize, is the difference in your rise over the difference in your run. Using that information, can we solve some problems? Well, in this case, we want to find the slope of the line through 1, 3, and 4, negative 1. And we could plot these 2 points and do our run and our rise over run, or we can use our formula, which is what we're going to do. So label these x sub 1, y sub 1, x sub 2, y sub 2. And it doesn't really matter which one's sub 1 and which one's sub 2, as long as inside, like if this is x sub 1, this has to be y sub 1. You can't interchange them. X sub 2, then this has to be y sub 2. So write this out. Y sub 2 is negative 1 minus y sub 1, which is 3. X sub 2 is 4. Let's do another example of using the formula to find the slope of a line. So let's call this one x sub 2 and y sub 2, and let's call this point x sub 1 and y sub 1. Again, it doesn't matter which point is the sub 2's and which point is the sub 1, as long as both the sub 2's belong to the same point. So I have my rise, my y sub 2, which is 0, minus my y sub 1, which is 2, over my x sub 2, which is 4, minus my x sub 1, which is 6. That gives me negative 2 over negative 2. Of course, that's 1 over 1. So that means my slope is 1. Here's another example. Again, it doesn't matter which one is x sub 1, y sub 1, as long as that point holds the sub 1's for both of them. My formula is y sub 2. Careful here because I've kind of changed these around. 2 minus y sub 1 over x sub 2 minus x sub 1. So I have 2 over, that becomes a positive, so I have 2 over 0. Now I can't have 2 over 0, so that's an undefined slope. Do you remember from a previous slide what that meant? What kind of line that was? That is a vertical line, because rise over run, and so it's a vertical line. Here we have our key concept, the slope formula. Get very, very used to that. You will need to know that. And when using the slope formula, the x-coordinate you use first in the denominator must belong to the same ordered pair as the y-coordinate you first use in the numerator. To find the change in the x or y coordinates, do you add or subtract? That is correct. You subtract. What number will you get in the denominator? If the x coordinates are the same, you will get 0. That is not good because that means it is a vertical line. Slide, we're going to look at 2 points, 4, -3, and 4, 2. Now look at that line. What kind of line is that? It is a vertical line. So the slope of this line is undefined. And I know we've went through it a couple times, but this is just a tricky part of this concept, so we want to make sure you really have it. We've gotten to the end of this video, so finish the last 2 slides and bring any questions you have to class tomorrow.